Let's explore condensed mathematics. This is a new foundation for topology and functional analysis, developed by Dustin Clausen and Peter Scholze. It's often referred to as the Clausen-Scholze Revolution because of the impact it has had in the field of mathematics. Traditional topology has certain limitations. One major issue is that topological spaces do not form a well-behaved category, making modern analysis and geometry difficult. Another problem arises in functional analysis, specifically with completed tensor products. Traditional topology also lacks proper foundations for dealing with liquid vector spaces. So, what exactly are condensed sets? A condensed set can be defined as a sheaf of sets on the site of profinite sets, where finite jointly surjective families of maps act as covers. The central idea is to replace topological spaces with certain sheaves of sets, in order to solve technical problems that come up in homological algebra. The work of Clausen and Scholze has brought about a significant shift in mathematical thinking. Condensed mathematics provides a unified framework that can be applied to algebraic geometry, complex geometry, and p-adic geometry. Furthermore, it transforms functional analysis into commutative algebra, resulting in well-behaved abelian categories. At a technical level, condensed sets are isomorphic to sheaves on profinite sets. Specifically, sheaves of sets on the pro-etail site of profinite sets, with finite jointly surjective covers, form the category of condensed sets. This equivalence is fundamental to the theory. Condensed mathematics has several key applications. It provides a unified treatment for complex manifolds, rigid spaces, and perfectoid spaces within analytic geometry. Additionally, it enables Serre duality and six-functor formalisms to be applied in a condensed setting within cohomology theory. The development of condensed mathematics can be viewed as a timeline. Between 2014 and 2019, Clausen and Scholze developed perfectoid spaces and the early foundations of condensed theory. From 2019 to 2021, they published the core condensed mathematics papers and conducted the liquid tensor experiment, marking a breakthrough period. Condensed mathematics is currently having a significant impact and is an active area of research. Major conferences such as Arbitagging 2023 have been dedicated to the applications of condensed mathematics. There is also ongoing formalization of the theory in the Lean theorem prover and exploration of new geometric applications. Looking ahead, condensed mathematics holds exciting future prospects. This includes potential applications to areas like artificial intelligence, machine learning, quantum computing, and computational physics. Further research directions involve continued development of formalization and integration with modern algebraic geometry. In conclusion, condensed mathematics represents a significant mathematical revolution. It provides a unified foundation that bridges algebraic, analytic, and geometric worlds. Clausen and Scholze have fundamentally transformed how we approach topology and functional analysis. The future of mathematics is being written today. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.